One more section on our quizzes for ionic compounds. This actually, and it's good to get your bearings whenever you work problems, I'm after the names for these compounds. And like I think I've said, what I would suggest is go ahead and writing the component ions, breaking it down, looking for the cation and the anion in each case. So if I break it down, let's see. Well, first off, let's look at the first one. You're like, what a mess. How does that work? Well, look for the cation and the anion. So can you see the cation here and the anion here? Okay, cation and anion. Okay, let's see. How about this one? Cation and anion. Okay, so I'm hoping that helps. So actually kind of here in a fell swoop in green are the component ions. So notice we've done a little bit of detective work to get some of these informations about these component ions. So for instance, copper, I'm going to put a question mark plus, okay? We know actually copper is one of those that forms multiple different types of charges. So can you see where we know NO3, we know NO3 is a -1. So actually in this case, the fact that there's two NO3s, okay, this must be a +2. Kind of do a little bit of detective work. Here for the lead, this one down here, the PbO2, well again, a little bit of detective work. We don't know, I'll put a question mark plus for that. We don't know what lead is going to form, cation, but we know oxygen's a -2. And notice, this is how I do this anyway. Notice that we have two -2s and only one of these. So do you see where that one must be a +4? Okay. All right. So let's go ahead and name these things. So for the first one, can you see NH4 plus, of course, is ammonium, and F- is fluoride. So ammonium fluoride is the name. Do we use Roman numerals for copper? Yes. So it's copper 2, what's the last name? Nitrate. Very good. Do we use Roman numerals for lead? Yes. So lead 4, remember that's where the V, of course, is 5, and if you put something before it, it means you subtract it. So actually, that's 4. So it's going to be lead 4 oxide. How about iron? Do we use Roman numerals for iron? Yes. In this case, it's going to be iron 2 bromide. And then I don't know why I fuss about this, but the Hg22 plus, that actually is a polyatomic, one of the two polyatomic cations you need to know for this class. So that is mercury 1, okay? And OH minus is, of course, hydroxide. Okay. So I'm going to switch it up a little bit, and for the last two slides, I want you to go ahead and write, and you're going to have to do this on a test. I go ahead and I give you the name. You have to write the neutral formula for the compound. Write the formula for the compound. So potassium fluoride. Now again, I would really strongly suggest you write the component ions and then crisscross. So you can find potassium on the periodic table. It's a 1A, so +1. Fluorine on the periodic table is a 7A. It picks up 1 electron, so it's a -1 anion. Crisscross, and of course we get one of each, right? Kf. Calcium, find out on the periodic table what charge does it form? A +2. Nitrate, what's the formula for nitrate? NO3 -1. So when you write the component ions, it makes it easier to know how to crisscross. How many calciums do I need? 1. How many nitrates do I need? 2. So I'm going to have to put nitrate, NO3, in parentheses. Very good. Aluminum chloride, these are both actually main group elements. I guess I should rather put it, aluminum is a 3A metal, so we can hang our hat on it forming a +3 charge, chlorine a -1 charge. When we write that down, it makes it more obvious how to crisscross. So we get 1 aluminum and 3 chlorines. Great. Nickel 3 bicarbonate. So the nickel 3 must be Ni +3. Bicarbonate is the same thing as hydrogen carbonate. So that's what? HCO3 -1. So now we know we're crisscrossing. I get so excited when I get to have, when I have to use parentheses and put the number outside the parentheses for the HCO3. Okay, so now on all of these formulas, notice I have not written the charges at all. You do not write the charges after you crisscross. So we crisscross, we need 1 nickel and we need 3 HCO3s. So we're going to put HCO3 in parentheses, and then outside of that put another 3. Silver oxide, now silver always forms a what charge? Silver is always a +1, and oxygen is a -2. So we have an Ag +1, O2 minus. If we crisscross, we have an Ag2O. All right, one more set. So you could be faced on the test with these names, and you have to write the formula. So again, I would write the component ions. So potassium carbonate. Now potassium, you're going to need to know is the symbol K. Find on the periodic table, it's +1. Carbonate is that CO3, 2 minus. Now if we crisscross, we have K2, CO3. Does that work for you? Copper 1 sulfite. Now know that sulfite is 1 oxygen less than sulfate, okay? So it's SO3 2 minus, isn't it? So Cu +1, SO3 2 minus. Crisscross, and of course you get Cu2 SO3. Iron 3 sulfide, so you're looking at Fe3 plus. Sulfide is what? S2 minus. I like these two because then you get little subscripts for each of them. So of course that means we need 2 Fe's and 3 sulfurs. Remember, do not put the charges in your formulas, your final formulas. So that ends up with Fe2S3. And also make sure that when you crisscross, you end up with subscripts for the number of the cations and anions you need. Barium carbonate. Barium is 2A, so it's a +2. Carbonate is CO3 2 minus. Now this is an example where if you crisscross, you get 2 of each, but actually to be correct, you need to, what we say, reduce that to 1 of each. Okay, if you can take the subscripts and divide them by a whole number and get another set of whole numbers, that's another way to look at it. So it's 1 of each, so BaCO3. Magnesium is a 2A metal, so it's a +2, and hydroxide is an OH -1. So in this case, we're going to need 2 OHs. So don't forget that if we need 2 of that, we're going to have to put OH in parentheses, and outside of those parentheses put the number 2. So it's going to be Mg quantity OH 2. All right, so you should be ready for this assignment.